So, well, good morning.
Good morning, ma'am.
Good morning, ma'am.
Good morning. So, Monday, I think we have completed acoustics and ultrasonics, right? And we have to start with nuclear physics. Chapter complete हो गया. I have started nuclear physics. या मुझे start करना है? Can anyone please confirm? Hello. हमने लास्ट में अकॉस्टिक्स ग्रेटिंग लिया था, राइट? एंड आई हैव टू स्टार्ट विद द न्यूक्लियर फिजिक्स. नया चैप्टर मुझे आज स्टार्ट करना है. ओके, थैंक यू. કેમ શું થયું? આ સંજયભાઈ ભૂલી ગયા. તનુજનો રિપોર્ટ હતો ને એ પડી ગયો હશે, ભૂલી ગયા. વાંધો નહીં, થેન્ક યુ. Okay, well, so let me start. See, nuclear and plasma physics is a combined chapter, a very small chapter. And if I talk about the 100 marks question paper, then from both the topics, maximum you can get the questions of 7 to 8 marks, right? But anyhow, we have to study as it is there in our syllabus. So there are few things which are given as a self-study part from this chapter, and a few things we will be doing. Because see, self-study we have given because there are few things which you have already studied, right? It's a kind of revision, so that's why we have given it as a self-study part. Now let me start in the nuclear physics. What you are going to learn is the fission and the fusion reaction. Difference between the fission and the fusion reaction. General features of a nuclear reactor, which you have already studied. So fission, fusion, and general features of nuclear reactor we are giving as a self-study part to you. And then after we will be studying two detectors, मतलब counters. The एक counter आप लोगों ने means you must have done in your lab, that is the GM counter, right? So GM counter is there in our as a theory part in our syllabus, and scintillation counter is also there, which is used for counting the gamma radiations, right? So though these are the self-study part, speedily I will just pass on from the slides, and then I will mail you the slide also. See, there are two types of nuclear reaction, fusion and fission. In fusion reaction, two light nuclei are combined to form a heavier nuclei, whereas in the fission reaction, a heavy nucleus is split up into the two lighter nuclei, right? So in both the process, there is the release of energy. Enormous amount of energy is released, right? Unlike the chemical reactions, we get the large amount of energy released during the reaction, right? Now, these are the few difference between the fission and the fusion reaction. Fission reaction does not occur naturally, and fusion reaction occurs naturally. It produces high amount of highly radioactive particles. Here, few radioactive particles are produced by fusion reaction, but it requires the fusion to trigger. Some triggering, some bombardment of the neutron is required to get the fusion reaction, right? Energy released is million times greater, but obviously in both the reactions, enormous amount of energy is released, but higher we get in fusion. The example is a fusion bomb. For fusion, the example is an hydrogen bomb, right? Then after, the general features of a nuclear reactor. So let me show you a video, and then after we can move on to the theory. Let me check if it is.
In this video, we're going to learn about the nuclear reactor. Nuclear devices extensively used for power generation, as the traditional fossil fuels like coal are at the verge of extinction. A nuclear reactor is the source of intense heat, which is in turn used for generation of power in nuclear power stations. Its mechanism is similar to that of a furnace in a steam generator. The steam is used to drive the turbines of the electric generator system. The nuclear reactor consists of three crucial components: fuel elements, moderator, and control rods. Fuel elements.
So see, these are the main parts of a nuclear reactor. A nuclear core is the main part of a nuclear reactor. Inside the core, we have the fuel rods. Matlab, if I am taking a fuel of uranium, then the rods of uranium will be taken. Means we need to convert the uranium into the form of a rod, and number of rods will be kept inside the reactor. Then you have the control rods and the moderator, which is used for cooling the system. કોમ્પ્યુટરમાં પાડી દીધું
ના પડી નથી ગયો હું કાંટે જ્યાં ગયો ને ત્યાં પૂછી ગયો ભાઈ રસ્તામાં આપણે બીમાર થયું છે
104 માંથી પેલા મેડમ છે ને આપવા આયા મેં દુરાવો એ મૂકી દો
come usually in the shape of thin rods of about 1 centimeter in diameter and contain fissionable nuclei like uranium-235 or uranium-238. These rods vary in number according to the size of the reactor. In large power reactors,
so see these fuel rods will be kept in a cylindrical form. Many rods will be there, and one more thing which is not mentioned here, these fuel rods, no, they are coated with some type of material to avoid the corrosion of the fuel rods, or like the steel, yeah, sometimes zirconium is also coated on these fuel rods, right?
thousands of fuel elements are placed close to each other. This region where these fuel elements are placed is called the reactor core. These fuel elements are normally immersed in water, which acts as a moderator. The objective of a moderator is to slow down the energy of neutrons in a nuclear reactor, which are produced during the nuclear fission process.
So the next part is a moderator. What the moderator will do, it will slow down the neutrons that are produced during the nuclear reaction, right? So that we can control the energy inside a reactor core. Because see, if the energy inside the reactor core increases, no, then there is a possibility of the blast of a reactor core. That's why you need to control the energy.
Nuclear reactor devices extensively used for power generation.
Correct?
Nuclear power stations. Its mechanism is similar to that of a furnace in a steam generator. The steam is used to drive the turbines of the electric generator system. The nuclear reactor consists of fuel elements, moderator, and control rods. Fuel elements come usually in the shape of thin rods of about 1 centimeter in diameter and contain fissionable nuclei like uranium-235 or uranium-238. These rods vary in number according to the size of the reactor. In large power reactors, thousands of fuel elements are placed close to each other. This region where these fuel elements are placed is called the reactor core. These fuel elements are normally immersed in water, which acts as a moderator. The objective of a moderator is to slow down the energy of neutrons in a nuclear reactor, which are produced during the nuclear fission process by the fuel elements. Thermal neutrons, which are the neutrons with energy of about 0.04 electron volts, are capable of producing fission reaction with uranium-235. During the fission reaction process, new neutrons are given out, which have energies of about 1 MeV. This is 1 mega electron volts. These neutrons typically escape participating in another fission process, as they are accompanied by enormous energy release. In fact, the probability of these neutrons producing another fission reaction is 500 times less than that compared to a thermal neutron. This is where a moderator is extremely useful. Moderators have the capability to slow down, or in other words, moderate, the speeds of these high-energy neutrons so that they can in turn be used for a chain reaction to trigger multiple fission reactions of other uranium-235 nuclei. Commonly, ordinary or heavy water is used as a moderator in nuclear reactors because of the deuterons present in them, which are capable of slowing down the neutron speed. Water molecules in the moderator are useful in slowing down the high-energy neutrons, which leave the fuel element after nuclear fission. These high-energy neutrons collide with water molecules, thereby losing out on some energy with every collision and therefore slowing down substantially. A new fission reaction can now be triggered using this slow neutron by striking it with the fuel element. The third and most prominent part of a nuclear reactor are the control rods. In order to get a steady output of energy from the nuclear reactor, every single fission reaction should trigger another fission reaction and ensure the availability of spare neutrons released to trigger the chain reactions. By controlling the number of spare neutrons available at any given time, the rate of nuclear fission chain reactions can be controlled. This control on the fission reaction can be maintained using control rods. The main function of the control rods is to absorb any excess or spare neutron in the moderator in order to prevent any further fission reactions. Usually, such control rods are made of boron or cadmium. To increase the rate of fission reactions, these rods can be removed from the moderator. A steady output of energy must be maintained by inserting or removing the control rods in the nuclear reactor. Now that we know the components of the nuclear reactor, let's understand the working of a nuclear reactor. It's usually enclosed in a shield made of thick concrete walls. It consists of a reactor core, pump, and heat exchanger. The reactor core and pump are placed in contact with water, which is usually the heat exchanger in these reactors. Due to the enormous amount of heat released during the fusion reaction, the surrounding water gets heated up and changes to steam, which is in turn used to turn the turbines. So huge heat energy gets converted into electrical energy. Water is continuously flown in and out of the nuclear reactor using the pump. So a nuclear reactor successfully generates nuclear energy from fission reaction.
Right? So almost all the things, means the main thing is what are the main parts of a nuclear reactor? A nuclear core. Inside the nuclear core, you have the fuel rods, and as I told you, it is coated with zirconium, yeah, sometimes steel. Control rods and the coolant, which is also known as a moderator, right? We have seen the function of a fuel rod, the function of the control rods, function of the coolant, yeah, moderator, and then after you have several reflectors. If anyhow any radioactive nuclei, if they escapes from the reactor core, they can be brought back again to the reactor core with the help of a reflector, and then a concrete shielding is there, right? And the energy, how it is used for generating the energy for rotating the turbine, that was explained, right? Then also I have tried to give you the use of each and every part of a reactor core, what it consists of, what is the function of a reactor core, fuel rods, coolant, everything I have tried to write, right? So you can just go through it. Already you have studied this, so that's why we have given it as a self-study part. Now the next part is a particle accelerator. the, before the nuclear reaction, we need to accelerate the particles. So in 1930, for accelerating the particles, this particle accelerator were determined, right? They were used for accelerating the particles, right, which are used for bombarding on the radioactive nuclei. So accelerator is the machine that accelerates the particles such as electrons or protons to very high energies, right? So for accelerating the particles, this particle accelerator are used. So this is an example of a circular particle accelerator. What it consists of? It consists of a particle source. जो one number है, that is a
Ma'am,
particle.
this particle accelerator means we need to accelerate electron,
Yes.
which we used in cyclotron, right?
Yes, right, exactly. Right? So this provides the particles such as protons or electrons. You will be having a source Then after, a beam pipe will be there. A very good beam pipe is there in BARC, right? Near the nuclear reactor, no, there is a separate chamber where these particles are accelerated. Underground beam pipes are there. Okay, so they have maintained it. No doubt, it's a reputed institute, but they are doing a nuclear reaction with the help of the particles. 3 or 4 types of particle accelerators are there at BRC. Right. So beam pipe. So beam pipe is used for sending the particles. It will be made up of metal, and your beam pipe has to be from the means it has to be free from the dust. Okay, otherwise it will disturb the motion of the particles inside this beam pipe. The third is an electromagnet. 3 number green color ones, they are the electromagnets. They are these electromagnets, they focus the beam of the particle when it travels through the pipe. Okay, so they are used for focusing. Compress करने के लिए we are making use of the electromagnets. Electric field, they will be given surrounding the metallic pipe, so that the electric field, they accelerate the particles from the positive end to the negative end. Then the target will be there. Number 5 is the target, right? On which the electrons, yeah, on which the particles are to be bombarded. So it will be, the target will be in the form of a foil. Yeah, sometimes a strip will be there. Then after, you have a detector just after the particle. So the detector will detect the particles after colliding with the target, right? So continuously with the, in short, continuously with the help of the magnetic field, the particles are accelerated inside the beam pipe. We are not detailing, we are not going to detail it. Just for your information, we have kept here the particle accelerator. I think you have studied 2 type of accelerators are there, linear accelerator and the circular accelerator. Linear accelerator is also known as LINAC. Okay, LINAC is used in RAM करके एक institute है at Indore, right? So there they are using LINAC, और एक दिल्ली में LINAC use करते हैं for accelerating the particles, right? दिल्ली में IUC मतलब Inter University Accelerator Center is there. So there people are there, they are using LINAC, high beam LINAC and low energy LINAC. They use this. Circular accelerators, I think, as per my knowledge, it is only at BRC. They also use LINAC, but they are generally using the circular accelerator only for accelerating the particles, right? So there are 2 types of accelerator, linear accelerator and circular accelerator. Fine. So how the particle accelerator work, explain here. You can just go through it. I would like to focus on detectors. Right. Now, what are these detectors? Detectors are the devices which detects the radioactive particles. They are also known as a radiation detector, right? Just like the hunter. Hunter जो है, शिकारी जो है, what by the trace of the foot of the animals, ना, they can trace कि भाई XYZ animal ये side गया है. उसी तरह this detectors, ना, if at all a single radiations are present, ना, they can easily track the radiations. Like detectors can easily track even a single radioactive radiations present in the given space, right? So we are going to study the 2 detectors, that is a GM counter and a scintillation counter, right? So in experimental physics, nuclear physics, a particle detector is a device used to detect the track or identify the ionizing particle that are produced by the nuclear reactions. Detector can also measure the particle energy, like momentum, spin, charge. These are these provisions are there in almost all the detectors. Now, how a detector works? Just as hunters, no, they can identify the animals from the track in a mud. Physicists identify the subatomic particles. Subatomic particles mean this radioactive particles from the traces they leave in the detector, alpha, beta, and gamma, right? So they leave some traces. जैसे bubble chamber करके एक detector आता है. So bubble chamber is of a size of, it's of a very huge size, And if any beta particles are there, na, if they are present inside the given chamber, na, there will be some cameras placed inside the bubble chamber. So when beta particle passes through the space, no, they ionize that space. So ionization की वजह से कुछ spark या ऐसा produce होगा. So if the camera will record that. Camera will take a snapshot of that what you say, this spark, and from that this nuclear physicists, they identify the radiations. It was there initially, bubble chamber was there in our syllabus, but now we are not teaching. We have removed it from the syllabus क्योंकि थोड़ा lengthy हो जाता था. Right? So this is a history of the detectors, the different types of detectors that are used. The main is two: gaseous ionizing chamber and solid state detector. Gaseous ionizing chamber में you have the 4 different types of counters या detectors: ionization counter, GM tube, spark chamber, and proportional counter. Right? After this, we are going. We will be studying only one, that is a GM tube. GM counter is a counter, no, that will detect all the types of radiation. You must have seen in the laboratory, alpha, beta, gamma, right? तीनों के तीनों radiations वो detect कर सकता है as a whole. It cannot identify कि this many number of alpha, beta or gamma particles are emitted, but as a whole, it can track all the 3 particles. Then after, in the solid state detectors, we have 3 types. Sanko counter, semiconductor counter, and scintillating counter. This is the first counter is not that much used, but scintillation counter are widely used for detecting the gamma radiation, right? It may be there are different bifurcation. Semiconductor counter can be made up of silicon counter, diamond counter, or germanium counter. But from this, इतना सारा nuclear physics हम लोग नहीं पढ़ने वाले हैं. Only the 2 detectors, GM counter and the scintillation counter. GM counter is also known as a GM tube, right? So let us start with the GM counter. I think let me show you a small video and then I can go on to the counter. We have already, all of you must have done the practical of a Geiger-Müller tube, right? So Geiger-Müller tube is a device. It is a detector that is used for detecting all the 3 types of radiations. It is usually, GM tube is usually cylindrical in shape, right, with a wire at the center. If you can see in the figure, let me explain you, I think, first, then we can go for a video. Right. So, हाँ बोलो.
मैम वो न्यूक्लियर डिवाइसेस में न्यूक्लियर रिएक्टर में फ्यूज का क्या काम होता है?
किसका?
फ्यूज आता है ना, मतलब वो ईरान का भी बहुत कुछ हुआ था ना, बहुत केसेस आते कि फ्यूज में पकड़ा गया हो ये सब में.
फ्यूज का?
हाँ, वो मतलब पावर जनरेशन में कुछ न्यूक्लियर एनर्जी का यूज करते हैं तो फ्यूज आते हैं, वो पहले के टाइम में यूज करते थे.
अच्छा. I don't have idea. Sorry. मतलब after the ये energy generate करने के बाद फ्यूज का यूज करते हैं outside the reactor. रिएक्टर के बाद
मतलब वो न्यूक्लियर मटेरियल होता है ना, जो वो फ्यूज ऐसा कुछ होता है, वो ही नहीं पता.
वो तो फ्यूजनेबल मटेरियल, मतलब यूरेनियम, उसको आई डोंट नो, उसको फ्यूज बोलते हैं, हम तो उसको फ्यूल रोड से बोलते हैं. फ्यूजनेबल मटेरियल या तो यूरेनियम या जो भी आप यूज करते हो वो होगा.
हाँ मैम, ऐसा ही कुछ होता है वो.
हाँ, तो दैट इज अ फ्यूल रोड, वही तो मेन है ना. विदाउट अ फ्यूल रोड आपका रिएक्शन जो है वो होगा ही नहीं. यू रिक्वायर अ रेडियो एक्टिव न्यूक्लियाई फॉर अ न्यूक्लियर रिएक्टर, राइट. मतलब मिनरल और उसको बोलते हैं, ओ आर ई, और. ओके, विद द हेल्प ऑफ विच द न्यूक्लियर रिएक्शन ऑकर्स. सो वो मैंने सुना है, राइट. या फ्यूज बोले तो मुझे लगा फ्यूज का तो कहाँ, राइट. सो दैट इज अ रिएक्टर, यू कैन से हैवी न्यूक्लियाई, रेडियो एक्टिव मटीरियल, यूरेनियम या थोरियम जो भी ये लोग यूज करते हैं वो. सो वो तो अभी मतलब अभी मिनरल्स आर ऑल्सो अभी उसको क्या बोलते हैं, कम होते जा रहे हैं. सो मे बी कुछ किया होगा. So that is the main part ना, जो fuel rods होते हैं reactor core में. So that is made up of your fissionable material only, uranium ही. Okay. So maybe उसी का होगा. Let us guess कि वही होना चाहिए. Fuse तो नहीं होता कुछ.
हमें वैसा ही कुछ होता है, वो यूरेनियम या थोरियम का कुछ ऐसा यूज करते हैं।
हाँ, वो फ्यूज मतलब ये फिजनेबल मटेरियल जिसके रॉड्स बने हुए होते हैं.
हमें मैम मैंने ऐसे फोटो में देखा है, वो मतलब ऐसे न्यूक्लियर मटेरियल को हाथ से पकड़ सकते हैं।
ना
हाँ
आपको नहीं पता. ऐसे इफ यू टच इट ना, इट मे अफेक्ट योर जनरेशन ऑल्सो. अगर गलती से भी कहीं बॉडी के अंदर चला गया ना, so it is going to affect the next generation also. There are nuclear hazards. हम लोग gamma radiation का practicals करते थे. We were using this thorium source, and even we have used uranium also when we were in MSc, because I was my specialization was in nuclear physics. So we have to wear a kind of dress. Okay, वो shielding वाला dress पहन के फोर्क जैसा आता था, उससे हम लोग जो मटेरियल है ना, वो हम टारगेट जो है वो लेते थे. एंड उसके लिए ना एक क्लोज्ड चेम्बर थी, ये रेडियो एक्टिव न्यूक्लियर मतलब मटेरियल रखने के लिए. देयर वाज अ सेपरेट चेम्बर. जैसे हमारा स्टोर रूम होता है ना, वैसे एक टनल टाइप की चेम्बर, और उसके अंदर भी लेड के कपबोर्ड्स बने हुए होते हैं. उसके अंदर मतलब डिफरेंट डिफरेंट स्लॉट्स होते हैं. वो स्लॉट्स के अंदर वी यूज टू कीप द सोर्स को वो पूरी लेड की मतलब अप्रोक्सीमेटली 10 सेंटीमीटर जितना उसका विड्थ होता है, उतनी चेम्बर होती है. और दो लेड के बीच में वहां पे मड मतलब रेती बोलते हैं ना, वो भरी हुई होती है पूरी. सो उसमें से वी यूज टू टेक आउट द सोर्स. scintillation काउंटर के जब हम प्रैक्टिकल करते थे, we were using these scintillation counters, right? So it's very hazardous. We can't touch it. Even हमारे प्रोफेसर भी हमारे साथ साथ ही आते थे. They were not taken out because हमको ट्रेनिंग देनी होती थी. तो we used to take the source from that storeroom and then प्रैक्टिकल करने के बाद वापस उसको रखना. वो हम लाते थे ना, वो भी कवर करते रहते, because this source no, they continuously emit the radiations. So हमारी लैब भी थी ना, वो हमारे डिपार्टमेंट में एक कोने में थी. दूसरे जो लैब्स होती थी उसके साथ नहीं थी. ओके, वो सेपरेट ही रहती थी. सो ऑल दिस थिंग्स यू कांट टच इट. हमारे पास जो सोर्स है ना, वो सोर्स के ऊपर हमने ट्रांसपेरेंट प्लास्टिक का कवर लगवा दिया है, ताकि अगर कोई भी स्टूडेंट मिसचिप करे ना, टच कर दे गलती से या मिसचिप करते हुए, तो वी कैन प्रोटेक्ट जितना हो सके. हम मीन्स वी हैव टेकन प्रिकॉशंस. बट अगर टच कर लिया तो इट विल अफेक्ट. Okay, this you can't play with this source. What we used to do ना, ये GM काउंटर के प्रैक्टिकल में लैब असिस्टेंट, जब तक आप लोग प्रैक्टिकल नहीं करते ना, तब तक हम उनको वहीं पे खड़ा रखते हैं. सोर्स लेने के बाद ही उनको बोला है कि आपको यहाँ से जाना है. एक बार सोर्स दिया मतलब यू हैव टू स्टैंड देयर. प्रैक्टिकल कर ले तब तक मैडम वहां पे खड़ी रहती थी, और फिर सोर्स लेके रखने के बाद ही वो वहां से जाती थी. So you have to take some care while using the radioactive sources. So okay, well, let me go back to the GM counter. So the GM counter, as you have studied, it consists of a cylinder. Okay, so this is a cylinder, a kind of aluminum tube which will act as a negative electrode, and a central wire which act as a positive electrode, right? And then after, the argon gas will be filled inside the tube. Inside the tube, you will be having the argon gas, और यहाँ पे you have a transparent window which is made up of mica. Transparent window means it is transparent for the radioactive particles, right? So I'll apply the high voltage between the anode and the cathode, right? Your central wire will act as a positive electrode, and the tube will act as a negative, मतलब cathode and anode. And then it will be connected with a high voltage. हमारे पास जो है, we can give 1500 volt to the GM tube, right? So high voltage is given to the GM tube. Now what happens when the radiation enters the tube? No, they get ionized, and because of that, the positive and the negative charges will be generated, right? So as soon as the radiation enters the tube, इसके अंदर argon gas होगा, right? So the argon atom, they get ionized, and due to which the positive and negative charges will be deposited. So as soon as the negative charge reaches the electrode, मतलब as soon as they reaches the anode, स्केल मीटर में आपको कुछ रीडिंग मिलेगा. जैसे 5 रेडिएशन एंटर हुए हैं तो आई विल बी गेटिंग 5 नेगेटिव चार्जेस. सो जैसे ही यहाँ पे रेडिएशंस जो है वो मतलब चार्जेस जो है वो इलेक्ट्रोड पे डिपॉजिट हो गए, आई विल गेट अ रीडिंग ऑफ 5 इन द स्केल मीटर, जो प्रैक्टिकल में आपने किया, राइट? दैट मीन्स the 5 radiations are 5 nuclear radiations are detected, right? So slowly what happens, continuously this radioactive source will be emitting the radiations. They will enter the tube, ionization hoga, and the positive and negative charges are deposited, are released, and the negative charges get deposited on the central wire. So what happens initially, you must have plotted the graph. यहाँ पे counts लिखा था, right? और यहाँ पे voltage लिखा था. So for the low voltage, very less ionization were there, and then at a specific voltage of 400 volt या 500 volt, you can see an increase in the count radiation, which 5000 4000 हो गया था. Then again an increase होता है. Then at a specific voltage, you can see the number of radiations, the number of count has become almost constant. क्यों? क्योंकि now the central wire is covered with the negative charge, shielding हो जाता है, right? So though you increase the voltage, there is no increase in the count. Okay, then after radiations ionization होते होंगे, but ये पूरा cover हो गया है, so it is not counting the radiations. Then it's a specific voltage, वो breakdown जैसा आएगा. Okay, when you apply the high voltage, the charges that were deposited, they break down and you get a sudden increase in the value of the count. So अभी आपका जो wire है वो clear हो गया, right? So इसको हम this is known as V0, which we tell as a starting potential. इसको हम Plato बोलते हैं, and this your Plato will decide the operating voltage of a GM tube. Okay, more the width of a Plato, the more will be the operating time for the given GM tube. So I think वही दिया है. It consists a tube is there which is filled with 90% argon and 10% ethyl alcohol. We can give a voltage of 1200 volt. Nowadays we are giving it a 1500 volt. And then how it operates. Okay, video है ही इसमें. Let me try. नहीं क्यों? Okay. Hmm.
When an ionizing radiation enters the compound, primary ionization takes place and a few ions are produced. These ions are accelerated with greater energy due to the high potential difference. They cause further ionization, and these ions are multiplied by further collisions. Thus, an avalanche of electrons is produced in a short interval of time. This avalanche of electrons on reaching the anode generates a current pulse, which, when passing through R, develops a potential difference. This is amplified by electronic circuits and is used to operate an electronic counter. The counts in the counter are directly proportional to the intensity of the ionizing radiation. The ionization of the gas is independent of the type of incident radiation. Hence, diagram on the counter does not distinguish the type of radiation that enters the chamber.
Right? इसमें कुछ खास नहीं है, but it's okay. So working, okay, fine. See this. This I have drawn a starting voltage, a Plato region, and then you will have a continuous discharge, right? Almost, I think I have explained you all the things. Okay, sometimes if you are asked to find the efficiency of a detector, it is given by the number of particles of radiation detected divided by the number of particles of the radiation emitted. So some of the advantages, they are inexpensive, means 60 to 70,000 में आती है GM tube, including the counter. They are durable and easily portable. Means you must have seen in a video, it's having a length of approximately 10 centimeter, 10 to 15 centimeter. So you can keep it anywhere. They can detect all the types of radiation. Now, what will be the disadvantage? We cannot differentiate between the alpha, beta, and gamma. Right? As a whole, as a lump sum, total radiations can be detected. They cannot be used to determine the energy of the radiations. Right? This is one of the major. Energy find नहीं कर सकते. Whereas gamma radiation के लिए जो scintillation counter है ना, with the help of the scintillation counter, we can detect we can find the energy. A GM will not give you the energy, and they have a very low efficiency. मतलब 8 से 10 साल तक ही GM ट्यूब जो अभी मतलब लैब के लिए है, it can be used, not more than that. The next is scintillation detector, right? So the scintillation detector, it uses a scintillator, right? What is a scintillator? It is a material that shows the fluorescent property when the radiations falls on it. Scintillation later is a material that exhibits scintillation, the property of luminescence when excited by the ionizing radiation. So when the ionizing radiation falls on the scintillator, it shows the fluorescent property. And it will emit fluorescent property, मतलब वो radiation को optical energy में convert, light के form में convert करके it will give the light. So what is the principle of the scintillation detector? See what it consists of. A scintillator will be there, and then after a light sensor will be there. Okay, so these are the ionizing radiation. Ionizing radiation matlab ki the nuclear radiations that are falling on the scintillator. If you see here, yellow color one is a scintillator. The radiations are falling on it. Just after the scintillator, you have PMT, that is the photomultiplier tube. Because there's the एक radiation enter हुआ, right? So one radiation will fall on the scintillator and it will be converted in the form of the light. So a single photon is difficult to be detected. So for detecting the photons, we are using a photomultiplier tube. So photomultiplier tube क्या करेगा? एक photon को detect करके, that will not be visible by us. So it will multiply it twice, thrice, 100 times, and at the output you will get the current. Right? Suppose n times multiply किया है तो आपको current की value original current से n times मिलेगी. So you need to convert it. Right? एक photon को 10 में convert किया है. So you must know that I have used the 10 PMTs. 10 times मैंने उसका multiplication किया है. Right? So I need to divide it by 10. 200 photons मुझे मिले हैं. So output में, that means if I have used 10 PMTs, that means the 20 photons are detected. 20 photons are detected, matlab 20 radiations must have collided with the scintillator, right? ऐसे calculation करते हैं. So what is a scintillator? It consists scintillation detector. It consists of a scintillator. KBr crystal sodium iodide या KBr crystal यहाँ पे होता है. It acts as a scintillator for ionizing radiation. Yeah, for the nuclear radiation. So when the nuclear radiations they fall on the scintillator, the scintillator will show the luminescent property and it will emit the photon. So that photons will be allowed to fall on the यहाँ पे light sensors होंगे, and light sensor will sense the photon, and then after it will be multiplied with the help of the photomultiplier tube, and at the output we will be getting that radiations in the form of a current, right? You can see here we'll get it in the form of a current at the output. So at the output, based on the current, the calculations will be done, and you can find the number of radiations that are falling on the scintillator, just like here. So you have an ionizing radiation, a sodium iodide crystal is there. So as soon as the radiation falls on this sodium iodide crystal, photon will be generated, which will be detected by the light sensor, and then after it will be sent to the PMTs. So first reflection 1K3, this you can set with the help of the PMT. Its PMT is again a tube. It's a kind of device only. We will not detail it, but it will multiply the photons. Right? So for the photo multiplier tube will do the multiplication, and at the output you will get the photons in the form of a current, which will be then analyzed. So the scintillation detector is a counter. Is obtained when a scintillator is coupled to an electronic light sensor such as photomultiplier tube, photodiode or PM. Generally, we are using the photomultiplier tube only, right? And same thing, just like the photoelectric effect, the PMT will convert the photons in the form of the current. So that's all. अभी ये चैप्टर बाकी है, प्लाज्मा मुझे लेना है. So I think I will not be in a condition to complete plasma today. सैटरडे कुछ एक्स्ट्रा लेक्चर है आप लोगों का?
शायद महेश सर लेने वाले हैं।
टेट्राई का हो सकता है।
टेट्राई का हो सकता है।
टाइमिंग भी पता नहीं चले सर, मैसेज करने वाले हैं।
कब करेंगे?
आज कर देंगे शायद।
मैं
11 के बीच में होगा, 10 to 11. Okay, so let me check if I can take. वैसे तो हो जाएगा, नेक्स्ट वीक में हमारे पास 3 घंटे हो गए. I'll be able to complete, बट अगर न कर पाए तो फिर LPW के बाद 1 घंटे का मुझे मतलब थोड़ा डाउट है कि लास्ट फ्राइडे गया ना हमारा, सो एक आध 2 टॉपिक रह जाए ऐसा. लेट मी चेक. महेश सर ना, आई विल टॉक विथ हिम. अगर ऐसा कुछ है देन आई विल सेंड यू द लिंक. और नेक्स्ट फ्राइडे छुट्टी नहीं है, राइट? तो फ्राइडे हमको 2 घंटे मिलेंगे. एक ट्यूट का मिलेगा 1 घंटा और 1 आवर विल बी गेटिंग. नहीं, आपका ट्यूट तो ट्यूसडे होता है ना? ट्यूसडे एंड मंडे.
Yes, ma'am.
So I can do one thing कि ट्यूट मतलब अकॉस्टिक्स के सम हमारे हो गए हैं कि बाकी है? बाकी है. तो मंडे में कंबाइंड ट्यूट ले लो 5 to 6. आप लोग फ्री हो पूरा क्लास?
And one batches, ma'am, has no lecture 5 to 6.
4 to 5?
नहीं है lecture, ma'am, 5 to 6.
ओके. 4 to 5 फ्री हो?
No, ma'am. 4 to 5 we have lecture.
अच्छा, एक तो मेरा ट्यूट होता है T1 T2 का.
Yes, ma'am.
हाँ, वो तो
आपको
है ही.
हमारा
और
टाइम टेबल
T1
भेज
वाले
दी?
मेरा ट्यूट T2 का होता है और T1 वालों का कुछ होता है ऊर्जा तब 4 o'clock.
मैम 4 o'clock हम लोगों का सीपी का ट्यूट, कंप्यूटर प्रोग्रामिंग का ट्यूट होता है.
ओके, ठीक है. ओके, आई सी. चलो करते हैं कुछ.
मैम बट 5 to 6 किसी का भी कोई भी लेक्चर नहीं होता, तो आप उस टाइम ले सकते हो.
मैम जैसे आपको कन्वीनियंट रहे.
मंडे को.
Okay.
ठीक है, ठीक है. और ये किसी कोई लिख रहा है N3 के ट्यूटोरियल खत्म, लैब खत्म हो गई है तो, पर ट्यूसडे वेडनेसडे छुट्टी है. 26 है ना, तो छुट्टी होगी.
No, ma'am, we have practical on Tuesday. और
वो N3 का वेडनेसडे को होता है.
अच्छा, ट्यूसडे N1 N2 का होता है.
हाँ मैम.
हाँ, बट मेरा लेक्चर होता है 12
11 to 1.
और 12 बजे के बाद में ले सकती हूँ.
ओके मैम.
ओके.
ओके मैम.
N3 फ्री है तब?
यस मैम, आप फ्री है ट्यूसडे को.
ठीक है, देन आई विल सेंड अ लिंक. ओके, फाइन. आई विल सेंड अ लिंक. आई विल टॉक विथ अंकुर सर. अंकुर सर लेते हैं आप लोगों का लैब?
नहीं मैम, N2 में पार्थिव सर लेते हैं.
पार्थिव सर लेते हैं. N1 में भी.
N1 में भी.
ठीक है, ठीक है. तो मैं पार्थिव से बात कर लूंगी. ठीक, कोई बात नहीं. ओके, ओके, थैंक यू.